Hello my dear students, hope you all are fine and interested in learning 11th physics. In continuation with the motion in straight line, we shall deal with the topics derivation of kinetic equations by graphical method and by calculus method, and we will do some of the numericals here. So, first of all, we need to derive the equations of a motion by kinetic equations of motion. In 9th standard you might have studied V is equal to V naught plus AT. It is the first equation, and the second is equal to S is equal to V naught T plus half AT square, and the third one is V square minus V naught square is equal to 2AS. These are the three equations which we are going to derive today by both the methods, in which we are having some assumptions where V is equal to, V is the final velocity, V naught is the initial velocity, and S is the displacement, and A is the acceleration, these are the basic consideration. Moreover, T is the time taken. So, these are the three equations which we are going to derive today, and these are the assumptions. V is the final velocity, V naught is the initial velocity, S displacement, A acceleration, and T time taken. Let us consider a body is starting from point A, having initial velocity say V naught, and the initial position is say S is equal to 0, and the time taken is say T equal to 0, and attaining, due to the acceleration, attaining the velocity V here, say the point is B, and the distance covered is say S, and time taken T is equal to T. Here in this case, we have to keep in mind that during the derivation, this derivation of kinematic equations, uniformly accelerated motion is considered. So, for uniformly accelerated motion, that is A is equal to constant, that is A is constant. Now, for this we will consider for uniformly accelerated motion. Let us draw the graph for this, that is Vt graph, say this is T and here T is equal to 0, and initially the object is starting with the velocity V naught and reaching a point V. We can draw the graph like this, say this is the time T, instead of here we can take here, and this may be the initial velocity V naught, and parallel to this is the velocity V, that is the final velocity. This is the initial velocity and this is the final velocity. We can join like this. Let us name it as O, A, B, C and D. The time taken here is T, and this is the initial velocity, say it may be taken V naught up to this it is V. So, what will be this BC is equal to V minus V naught. This is the graphical one. By graphical method we are dealing now. First one, we are going to derive the first equation, V is equal to V naught plus AT. By definition, we know that acceleration is equal to change in velocity by time. Change in velocity by time. Here what is the change in velocity? That is final velocity minus initial velocity. That here the final velocity is V and the initial velocity is V naught. By the time taken is T. So, we can write like this. So, further AT is equal to V minus V naught, or we can write V is equal to V naught plus AT. Thus, we arrived at the first equation, that is by definition A is equal to change in velocity by time. Here we have change in velocity, that is the object is starting from the velocity V naught and due to acceleration, uniform acceleration, it is arriving at the final velocity of V taking time t. So, V minus V naught by time taken t, that can be written as AT is equal to V minus V naught and V is equal to V naught plus AT. This is the first equation, which is relating to initial velocity, final velocity, acceleration and the time taken. Okay. In the last class we have discussed that displacement is nothing but a area covered by the VT graph, area covered by the VT graph. So, we can write area covered by VT graph gives the displacement. Area covered by the VT graph gives the displacement. So, what is the area covered by the graph here? O, A, B, C, D. So, we can write S is equal to area covered by O, A, B, C, D. Now, as we are seeing here, two parts of this are there, that is OACD and ABC, that is a rectangle and a triangle. So, we can split and find the area and add it. So, area of a rectangle plus area of triangle. So, area of rectangle is length into breadth, that is T into V naught, or we can write V naught into T plus area of triangle is half base into height. So, half, what is base here? AC is the base which is equivalent to T. So, we can write T, and what is the height? BC is the height, and we know that BC is V minus V naught. From equation 1 we have V minus V naught is equal to AT. So, we can put the value of V minus V naught in this equation. We will get V naught T plus half T into AT. Thus, we can arrive at the equation, that is V naught T plus half A T square. This is the second equation we have arrived. This equation is related to the distance, initial velocity, time and acceleration. In this equation, we are not having the term final velocity. We have derived the two equations and we shall go for the third equation. We know that average displacement is equal to the average velocity into time. In the last class we have studied displacement is equal to average velocity into total time taken. What is the average velocity here? We know that the object is moving with uniform acceleration. So, this is the initial velocity and this is the final velocity. Where will be the average velocity? It has to be in the center. Mathematically, the average velocity is the initial plus final velocity by 2, average of that. So, we can write V equal to V plus V naught by 2. Therefore, we can have S is equal to V plus V naught by 2 into T. From equation 1, we can have we know that V is equal to V naught plus AT. So, from this we can have T. So, V minus V naught by A is equal to T, that is V minus V naught by A is equal to T. So, we can put the value of T in this equation. So, S is equal to V plus V naught by 2 into, in place of T, V minus V naught by A. Therefore, we can have 2AS, bringing here 2AS is equal to, this is V plus V naught into V minus V naught, that is A plus B into A minus B, that is A square minus B square. So, we can write V square minus V naught square. So, collectively V square minus V naught square is equal to 2AS. So, we have arrived at the third equation. What does the third equation related? It is related to final velocity, initial velocity, acceleration and displacement. Here the time is not concerned. So, we have arrived at the third equation. Now, we shall go to the second method of derivation, that is by calculus method. For the first equation, that is V is equal to V naught plus AT. This is what we have to derive first by the calculus method. By definition, we know that A is equal to dV by dt, that is change in velocity by change in time. This can be written as dV is equal to A dt. Now, this is in differential form, we need to integrate so that we can get the value of V. So, integrating both sides, dV from V naught to V, that is initial velocity to final velocity, A integral of dt, that is from t is equal to 0 to t. Integral of dV is V, having limit of V naught to V is equal to A, which is a constant, and integral of dt is t, limit of 0 to t. Now, giving upper limit minus lower limit, we can write it as V minus V naught is equal to A into t minus 0, or else we can write V minus V naught is equal to AT Further, it can be written V is equal to V naught plus AT. Thus, we arrived at the first equation of motion. Let me repeat it. By definition, we know that A is equal to acceleration is equal to change in velocity by change in time. So, we can write here dV is equal to A dt. So, we need to integrate with the limit of initial velocity to the final velocity equal to A is a constant, that is why taken out dt, integrating dt 0 to t time. So, integral of dV is V and limit of V to V naught is equal to A, integral of dt is t, limit t to 0. So, giving the limits, we know upper minus lower, V minus V naught is equal to A, upper limit minus lower limit, that is t minus 0. So, we can write V minus V naught is equal to AT, further simplifying V is equal to V naught plus AT. This is the first equation derived by the calculus method. Now, we shall proceed with the second equation. What is the second equation? S is equal to V naught t plus half AT square. This second equation we need to derive now. Okay. Second equation, that is S is equal to V naught t plus half AT square. Since it is related to the distance, we can write velocity is equal to ds by dt. By definition, velocity is equal to ds by dt, that is rate of displacement. This can be written ds is equal to v dt. So, ds is equal to, we can write v, that is v is equal to v naught plus at, that we can write here, that is v naught plus at dt. Now, we shall integrate both the sides having limit 0 s ds and integrating RHS, that is v naught plus at dt. We can further split ds 0 to s, this can be splitted and integrated separately. So, integral of v naught dt plus integral of a taken out t dt, the limit is 0 to t and v to v naught to v. So, integrating, we will be getting s, that is integration of ds is s and limit is 0 to s, that is equal to integration of v naught dt, integration of dt will be getting t. So, v naught t, here we need to change this, we are integrating with respect to dt. So, we will be having 0 to t here. So, limit is 0 to t plus a integral of t dt. Separately, let me explain this. Integral of t dt is equal to t square by 2, that is t to the power n plus 1 by n plus 1. We will be getting like this, that is t to the power 1 plus 1 is 2 divided by 1 plus 1 2. So, t square by 2. So, a by 2 can be written here, that is t square 0 to t. Now, giving the limit, upper limit minus lower limit, that is s, here it is 0, neglecting that, that is v naught t, 0 term is neglected, plus half a t square. Why? Because upper limit t square minus lower limit 0. So, we can write s is equal to v naught t plus half a t square. Hence, we arrived at the second equation. that is S is equal to V naught t plus half a t square. In this equation, we are dealing with the displacement, initial velocity, time and the acceleration. This gives the displacement equation. Let us go for the third equation, that is V square minus V naught square is equal to 2as. By definition, we know that A is equal to dV by dt. Further, it can be written as dV by ds into ds by dt. That is mathematical rearrangement in order to arrive at the required expression. So, A can be written as we know that ds by dt is V. So, V dV by ds. Further, bringing this ds here, it can be written A ds is equal to V dV. Now, integrating both sides, A integral of ds, that is 0 to s, equal to integral of V naught to V dV. We know that integration of ds is s. So, A s from 0 to s equal to, again integral of V dV is V to the power 1 plus 1 by 1 plus 1. So, integral of V dV can be written V to the power 1 plus 1 by 1 plus 1, that can be written V square by 2. So, here we can write V square by 2 having limit V naught to V. Now, giving the limit A s equal to, taking out this upper limit, taking out 2 and giving upper limit, that is V square minus lower limit, that is V naught square. Bringing this to this side, we can write V square minus V naught square is equal to 2as. This is what the equation we need to derive, that is V square minus V naught square is equal to 2as. This is the third equation. So, we have derived the three equations or kinematic equations by graphical method and calculus method. Now, we shall see some numericals. Let us do a numerical based on kinematic equations. The question is, a race car accelerates on a straight road from rest to a speed of 180 km per hour in 25 seconds. Assuming uniform acceleration of the car throughout, find the distance covered in this time. From the question we can get that a car accelerates on a straight road from rest. Rest, the word denotes that the initial velocity is 0. So, we can have here u equal to V naught is equal to 0, that is initial velocity is 0 and the time is given 25 second. So, t is equal to 25 second and attaining to the speed of 180 km per hour. This denotes that the final velocity is 180 km per hour. So, obviously, V is equal to 180 km per hour. Since it is in second and it is in kilometer, we need to bring all the quantities given in the question to a same SI unit. In order to bring this in meter per second, we need to multiply by 5 by 18. So, 180 into 5 by 18. So, we can get it, that is 10 into 5, 50 meter per second. Now, we got final velocity, initial velocity and the time. What is asked in this question? Find the distance. First, we shall write the formula for the distance, that is second equation of motion, S is equal to V naught t plus half a t square, that is S is equal to V naught t plus half a t square. In this equation, we need to find S. V naught we have, t we have, and a we do not know, and t square also given. So, in order to put the value in this, we need to find the acceleration first. From which formula we can get the acceleration? See the first equation, that is V is equal to V naught plus a t, that is V is equal to V naught plus a t. In this we know V, V naught and a t. So, obviously we can find the value of a. So, a is equal to V minus V naught by t. So, putting the value, final velocity here is 50 meter per second. So, 50 initial velocity 0 divided by time taken is 25 seconds. So, 25, it comes to be 50 by 25, that is 2 meter per second square. So, we found the value of acceleration. Now, we can put the value of acceleration in the first equation. So, S is equal to V naught t. What is V naught here? 0 into time 25 plus half, what is the value of a? 2, and t is 25 square. So, we can have S is equal to, this is 0 plus this 2 will get cancelled, we will have 25 square. So, finally, we can write S is equal to just a square of 25, that is 625 meter. So, we got the answer, that is the distance covered in this time means 25 seconds is 625 meter, that is the answer. So, in this question what was given? Rest denotes the initial velocity, and attaining speed of 180 km means the final velocity is 180 km per hour, and that can be converted into meter per second. Time is again given 25 seconds. First we need to put in the second equation. We find that a is not given. So, we go for the first equation, that is V is equal to V naught plus a t. From this equation we can calculate the value of a, that is 2 meter per second square. Putting the value of a in this equation, we will be getting S is equal to 625, that is the total distance covered in this 25 seconds. So, we have seen one numerical. On that basis you can do 2-3 numericals, so that you can get practice over such type of questions, and you may go for the other equations also. If you do the lot of numericals, that will give a sound knowledge in the concept of formulas. And further to say, we have seen derivation of kinematic equations by graphical method, by calculus method, and we have seen one numerical, and we will be continuing in the next class with the numericals and other part of concepts. Thank you.